Time for VUC. In our 11th year, with us on our journey this year, Simwood.com. Simwood can turn you as a developer into a telco. Greenfield Tech. Go to greenfield.tech and see how they can make your tech dreams both feasible and affordable. Our conference bridge is the best you'll ever find, zipdx.com. VUC.me is hosted on Bluehost. And our worldwide local rate dial-ins are provided by voxphone.com. All right, very cool. And while I switch cameras, yes, this is the VUC 656th edition for July 28th, 2017. And our special guest is Dr. Paul Gardner-Stephen, who has been very patient with us. Thank you, Paul, and welcome to the conference.
My pleasure.
And I'm not going to explain all this. We'll just get right into the fact that we've got Michael Graves with us, and we can't see him right now. So I'm going to instead present our favorite, Mr. Corrado Mela.
Okay. Good afternoon, good morning, good evening. Hello, everyone.
There you go. That's his signature, by the way.
Yes.
So we're going to be, we got late because of some ZipDX routing issues, and we had a combination of things because suddenly I couldn't get in either for totally unrelated reasons. We're here now. And as I warned you, Paul, we're going to get into your background, starting with whatever brought you to tech in the first place, before we talk about the Serval project.
Sure. So I guess my beginning of tech, I grew up in the 80s. So for me, 8-bit computers were sort of where it really started. So the VIC-20 and Commodore 64 was sort of where I cut my teeth. And we still do a bit of mucking about on those things today. But I think, the simplicity of computers in that era made it much easier to learn to program and to think, well, what can I make a computer do? What do I want to make a computer do? And I guess, setting me on that journey of making computers do what I want them to do rather than maybe what other people have already made them to do. So I guess that was really formative in my whole approach to computers, and of course that's then led through in work with the Serval project to try and solve these problems that other people haven't been trying to solve in disaster and remote communications.
Okay, so the name Serval project. Serval,
yeah, so,
I'm guessing.
Yeah, so the genesis that was actually quite simple. We started what we were doing, and my wife and I were at the local zoo, thinking, what would be a good name for this. We went past the Serval cats and thought, yep, that's short, easy to spell. Turns out, unfortunately, that some people call them Servals, we call them Servals in Australia, and no name is ever perfect, but we like the Serval cats. And then actually afterwards, as we were reading a bit more about them, we found out some very interesting and appropriate things about the things. So on the back of their ears, they have these white spots that the mothers will actually basically flick the spots back to their kittens back in the tall grass, and actually so they form their own mesh networks in the savannas in Africa. So that was a really nice, but we must concede, entirely accidental connection. And Servals have long legs and a surprisingly high effectiveness at hunting as well. So we kind of like to look to those attributes as well.
Interesting. And the application that we're talking about, by the way, we should say that you can go, it's very easy to get this. This is on, first of all, the app required for this is a mesh app that is Android only for the moment, correct?
That's right. We do have an iOS port underway. We're actually hoping to try and revive some of the work on that between now and Christmas and get at least an alpha version available somewhere. But yeah, at the moment it's Android only. We're actually in the process of completely overhauling the app at the moment. So the Serval Mesh app will become Serval Chat in coming months, and that will have the existing text messaging function. But we're actually also adding in a microblogging feature, similar to Twitter, which is actually, it's a very natural use for this kind of store and forward network, and we can talk about that as we go on as to why that's the case.
Now, we definitely will get into the applications and where it's been tested. Let's get to, by the way, really quickly, get to the blog. Now, even though I've read all this stuff, I've forgotten the URLs. Is everything on the same URL at servalproject.org, or is there a blog dot and so on?
There
Where do
is
we
a
read?
blog as well. I've just popped into IRC as well. So servalpol.blogspot.com.au.
Okay. And I will eventually get this up on the screen on the video. And so you can follow the adventures, and we'll talk about some of that stuff, I think, with you, Paul. But the most interesting thing, so when we started talking about this amongst ourselves, and a couple of people aren't here, one of the comments was, well, it only works with Wi-Fi. So we should probably get into, before we get, I know there's an extender and there's radio connections and so on, but let's talk about the first scenario, which is it works on Wi-Fi. Now, as I said, I installed this on one phone. Oh, the first objection was, well, how do you get it on your phone if you don't have internet? So I installed it on Google Play because it's there. It's a free app. You install it on your phone. I then transmitted it via Bluetooth to my other two phones, one of which does not have a SIM. And that's a significant thing in and of itself, because you may not have SIMs on these phones. So I think that's probably a good starting point for you to say how this stuff works, because, the point is these are extreme situations, and you might have cheap phones that don't have SIMs. Go ahead, Paul.
Exactly, because as you sort of indicating there, the primary use case that we set out to solve was, how do you deploy a telecommunications network in a disaster? And of course, a disaster is defined by the lack of sufficient logistical support and infrastructure to meet the need at that time. So we wanted a system where, a bit like the flu or the plague, if one phone caught it, the rest of the phones in that area could catch it. So once you have the app installed on one phone, you can transmit it by Bluetooth, or in fact by Wi-Fi if your phone will allow you to go into Wi-Fi hotspot mode. Once that's then transmitted to another phone, the phones can then communicate via either Bluetooth or via Wi-Fi. We started out with ad hoc Wi-Fi, but that needed root access. That was possible back in the Wild West days of Android back in 2010 sort of to 2012. Not anymore. So you can either do kind of the Wi-Fi hotspot client thing, but Bluetooth is a little bit easier for that. But in fact, the mesh extended devices that you were mentioning just before is really the grand solution to that problem. So that when getting Bluetooth links, or the range of the Bluetooth links is problematic, that we can actually form useful, interesting networks.
And we would definitely get into the radio extenders in a moment. Maybe this is the time for Corrado to ask his question about the various access things. And then I have some other things after. Corrado?
Yes. Well, when I installed the application, it asked a lot of permissions on my phone, between identity contacts and even Bluetooth connection, but also device ID and call information. That is probably one of the first impacts that the installer the people that are installing that will have. So the question is, because of the privacy and everything else, are all these permissions for the application required to run the application?
So we're actually in the process. So the new version of the app requires very few permissions, in fact, in comparison. So the current version of the app, because of the way it works, kind of needs to have its hooks in everywhere. Because if you like, we're being your telco when you're off the grid. And so we need practically every permission on the phone to do that. And some of that was, we had a mechanism where you could use the normal Android dialer and dial someone's phone number, and it would try and work out if they were on the mesh network and direct dial them on the mesh network. And that one feature alone needs about half of those permissions, because we have to intercept when you're dialing out and do all these kind of crazy things to make that happen. So we're not putting that particular function into the new version of the app, because I think the way people use their phones has changed over time as well, that people are now more used to going into an app, you know, whether it's like with WhatsApp or, you know, a bunch of these other things to make calls in alternative ways. And so, you know, we just don't see that that's necessary. And as you say, people, you know, you're not the only person who sort of said like, God, it's asking for every single possible permission on the phone. And of course, you know, in the early days of Android, the permission model wasn't very fine-grained either. So if you needed one little tiny thing out of one of these areas, you know, you needed to ask for the entire box and dice.
Yeah, of course. I also experimented on 3 different phones. Well, medium high range Motorola, a Moto G4, a semi-ancient HTC Wildfire, and an old Samsung young Samsung I or GT5330. By the way, these 2 last devices I mentioned didn't have any SIMs, and I transferred the APK, the application, via Bluetooth without any problem. There were some problems in one of the devices because it didn't have an SD card inside, but that is another thing. I can connect those 2 phones with each other via Bluetooth or the Wi-Fi network, but I cannot run and recognize and connect to the mesh with the Moto G4. What's the difference between these devices? The Moto G4 is stock and not rooted, while the other 2 devices are rooted. There are
okay, and so this root issue. So as I say, we've moved away from needing root. So in fact, even in the current version of the app, the only thing that you would ever need root access for is if you're trying to do ad hoc Wi-Fi, which on any phone newer than about 2012 just won't work anyway. So the root access is actually not an issue at all. And in fact, so in the new Serval chat app, it doesn't even try and check whether you have root access because we just don't use that anymore. So it really is historical. In fact, the existing version of the app is a direct descendant from the seething mess that we built back in 2010, where we got a SIP client, we got the entire Asterisk PABX, and various other things, and made them all run on the original, G1 Android phone. It really was like something out of, one of the Duck Dodgers or Marvin Martian Warner Brothers cartoons with the secret weapon of having to try and, you have to install these 3 APKs, untar this thing into the SD card, and with this whole complicated procedure. And we smoothed that out over time, but there were still some vestiges of this in the way that it asks for root access. That, as I say, we're now making a clean break to remove that distraction for people trying to use it, because it doesn't matter anymore anyway.
Okay, fantastic. I have to say, probably it is because the computational power of the oldest device is not good enough. Voice is a bit garbled, but on the other side, the HTC, it's working perfectly. So I can hear on the other side. Yeah, and so the voice calls is actually an interesting point. Everyone loves to make a voice call without a telco because it's kind of, there's an impact factor to it. But what we find in practice is that that's actually not a very important use case, because to do that, you need to have a real-time end-to-end link between the phones. So it works when you're within shouting distance, in which situations you don't need it anyway. And that text messaging and something like Twitter is actually much more useful features when you're in these situations. And so in the new Serval chat app, we're actually not re-implementing at this stage the live voice call function. We will add voicemail so that you can record a message to someone, because that can store and forward through the network over great distance, irrespective of what the network conditions are. And so that greatly simplifies a bunch of these things, because we found the audio delay on Android, particularly on older versions, was really horrible. And even on newer versions, you had to do a fair bit of work to get the audio latency down nicely, and then to enable echo suppression and all those kinds of things. It was really quite a complicated process for, in terms of
gain in these use cases that we're looking at was very small.
Yeah, in fact, there is a bit of a delay. It's perfectly acceptable. Is something that is satellite quality, so it's good enough. One thing that is really important is the store and forward of voicemail messages and text messages and everything else. Even yes, you can also share files, so you can take pictures of a disaster area and get that. Then relay that at a later time to someone else.
That's right, and that's something that we're looking to refine, because at the moment it's just kind of it's almost like a magic global Dropbox folder on the mesh, which is, from a user perspective, is not ideal. But like so many things in this, the existing version of the app, they're all proof of concepts of what's possible. And so I often describe it as a bit like being the second Death Star, in Return of the Jedi. The big gun works, but if you were to open the wrong door, you might get sucked out into the vacuum of space. And so we're trying in the Serval chat app to say, okay, let's make something that is a little more refined, a little more user-oriented, and much more pleasant and convenient to use.
Yeah, it's working as intended. Would it, if a number of phones are connected with each other, not in the same range of the Wi-Fi network or the ad hoc Wi-Fi, relay a connection to let's say there's one phone on one side of an area that is connected to a secondary phone, and that phone is connected to a third phone. Would these three merge together and be seen on the same mesh?
So if you connect, so if we go back again to the bad old days with ad hoc Wi-Fi, that works. With regular Wi-Fi on the phones today, it doesn't work. With Bluetooth on the phones, it usually works. And because Bluetooth, the interoperability is actually not perfect still on modern phones compared to what Wi-Fi is. But of course, with Wi-Fi, to do multi-hop, you have to use ad hoc mode, because no other mode will do that, which is, again, why we've made the mesh extended devices, to generalize that out and make it a whole lot easier. If Bluetooth is all you've got, then, hey, we do the best that we can with that, and you can potentially get a number of hops with Bluetooth. Okay. But really, the mesh extender is designed to be the more scalable solution to that problem.
Last question. I don't want to steal everyone's other questions, but there is also an option for the phone and Serval itself to become an access point, I think, if I'm not mistaken.
The phone can run Wi-Fi in access point mode.
Yeah.
In fact, if you don't have ad hoc Wi-Fi, that's the only way to get a Wi-Fi link between two phones in any really sensible manner. I mean, and Wi-Fi Direct is actually just a form of doing that.
Okay, so you could possibly have one phone in the middle of somewhere, creating an area where other people, whereas they can't see each other, they could relay between a third phone in the middle.
Yeah, correct.
Yeah. Okay, and how many hops can you do that? How many phones can connect to each other?
Well, you can only go one hop from that phone.
Yeah,
because every other phone is just a client to that phone. And we did think about having kind of some crazy scheme where the phone runs as an access point for a while, then becomes a client, and everyone tries to, flip and flop between the modes.
That was my thought. If you could create a network of different phones somewhere around and expand the network in that way, but probably is a bit complicated to do, because you have to be a client and a server.
Bluetooth is easier.
Yeah.
Okay, before we move to the extender philosophy, I just want to mention that I'm showing here the blog, which is at servalpaul.blogspot.fr. Well, I'm on FR. It's, what is it? It's
whatever you
can.
Blogspot.
Yeah, I don't know. Blogspot deals with that. Anyway, point is that this is very interesting, and I wanted to mention, because we're still on Wi-Fi for 20 seconds, that one of the fascinating things about this blog, Paul, is that you mentioned, at least I'm pretty sure you mentioned in the blog, that out in the middle of nowhere where the air is really, really dry, you actually eventually got up to 4 kilometers of Wi-Fi when it was up high. Right?
So, okay, so not of Wi-Fi, so 4 kilometers with the UHF packet radio.
Oh, UHF, sorry. Okay.
With Wi-Fi, we find, because the Wi-Fi antenna in a mobile phone is not that fantastic.
Right.
No. You know, like they're probably, you know, 10 dB worse than what you would have on a regular Wi-Fi access point. And so somewhere like Arkaroola, which is where we do our testing in the outback here in Australia, we find that we can get several hundreds of meters without too much trouble with Wi-Fi. Like we've seen, I think 300 or 400 meters between 2 G1 phones back when we were using those. And we've seen Wi-Fi links over, you know, 0.5 kilometer to 1 kilometer. We haven't tried to systematically work out what the limit is. What we do know is that the noise floor up there at 2.4 gigahertz is, you know, it's minus 99 dB or lower. It's a very, friendly environment for communications. And of course, you know, the air is very dry. So the only real sort of multi-path issues you have is things bouncing off the iron-rich ground. And likewise, of course, you know, the UHF around 900 megs goes quite nicely. And our main problem there actually is atmospheric ducting, we believe.
Okay, so here I'm on let me share this on the application window, and here we go. What are we seeing here? Oops, I don't see anything. Do you see this?
Oh, okay, yeah.
Okay.
So that's the earlier incarnation of the mesh extender. So this was a modified router, and we added in the packet radio. And so for probably 3 years or so, that was the form of the hardware that we were testing with. But of course, this wasn't weatherproof or anything. But let me just grab. I'm not sure if I have an image on the blog of the new one, but I have one of the
actual object. Maybe you have with you.
Yeah, I have one of the actual objects. I don't have the antennas fitted on at the moment, but this is our newly produced 3rd generation mesh extender. So we have injection molded tools made, and this is designed to be about IP65, IP66 ingress rated. So the idea is that you can attach this to a coconut palm on a Pacific island if you have need. And I think actually on that blog post, if you scroll back through, I think there's even a photo of me tying one of these to a coconut tree.
I think there may be. By the way, IP66, there is nothing further than that, is there? The 6s are the highest.
So IP67 is immersible for up to half an hour to 1 meter. IP68 is, I believe, you can operate it at reasonable depth underwater indefinitely.
But that wouldn't serve any purpose for what you're trying to do anyway. So the first six is that it's waterproof, that it is sealed, right? The first 6.
Yeah. So IP66, you can point a garden hose at it,
right,
and kind of try and squirt water in all of its orifices, and it should still keep working.
Right.
So we want to deal with sideways rain in a hurricane or cyclone situation.
You also had, and again, this is why the blog must be visited by people who are interested in this, because you also had some photos and some text about sticking a phone in a box and putting it on a tree or something. I don't know. You want to tell us about that?
In Vanuatu?
Yeah, exactly.
Yeah. So the first visit that we did, so a little bit of background. So we have funding from the Australian government. So the Australian version of USAID, so it used to be AusAid, it's now just part of the Department of Foreign Affairs and Trade. They're funding us to run a pilot with these new mesh extenders in Vanuatu, sort of at the moment through to the end of the year. And so the first visit, we were staying in a house about 20 kilometers out, so about 10 or 12 miles out from Port Vila. And in principle, it's an area that has 3G coverage in there. So that's one of the older ones, that image that we're seeing there. That's actually not in Vanuatu. That's actually in my backyard here in Adelaide. We've got banana trees down the back. But I think you'll find somewhere there that there's a shot of the newer one going on. Oh,
yeah, while you're talking, you're still on the focus so people can see you right now.
Yeah, sure.
There we go, right
okay,
there.
Sorry. Yeah, so we're out of Vanuatu, out of Port Vila, and in this relatively rural area. And as I say, in theory, we had 3G coverage. The reality was we had 3G coverage only when the atmospherics played nicely, and only if we had the phone outside and in a good vantage point. So it was, just trying to check email and do all the bits and pieces that we needed to do in support of the pilot. We were actually, in need of resilient communications ourselves, and had to resort to getting a clear plastic lunch tub.
Finally got it. All right, here it is. I'm showing this to everybody and try to get it so that it's
out on the barbecue outside.
There we go.
And pop that up, and then the local dogs came and had a sniff at it and kept knocking it down, and it was just, communications in these places is hard.
Right. Are there other photos? I mean, there's 31 photos. So if you wanted me to find something,
so there should be at least one of them that has me hanging the thing in a tree. So that one you're showing now, this is doing a fit test on a tower that we're planning to put it on one of the outlying islands in Vanuatu. So there's kind of three pilot locations we're looking at. One is in Port Vila itself, with the National Disaster Management Organisation, Red Cross, and a bunch of other groups, so that they have a network that they can, practice and play with in town. And then there's a couple of villages on the same island in an area that doesn't have good phone coverage. And then the third location is where this tower is going, out on an outlying island called Maiwo. So let me just find the with the coconut tree.
We got a solar panel on that.
Yes, there's one of the solar panels that's out the back from where we were staying when we were doing some testing.
I'm actually going backwards, which may or may not be a good thing. Because you've got some other photos that are just photos of the adventure.
So I don't yet have that photo up, because the photo I'm thinking of is actually from our second visit, which I haven't put the blog post up about. So the one with the solar panel is the one of the mesh extender deployed in there.
This is the one that all the dog lovers on the VUC will like this photo. Dog nosing it.
Yeah, that was the friendly dogs that were investigating our communication solution.
I'm kind of rushing through these, trying to find things that you would want to comment on in particular, because some of them are kind of incidental. That's the older one. Is there anything else in this series of 30?
Other than, so if you stop there, so this is actually in one of the villages that we're looking to run the pilot in, and so it gives you a sense. So this is the chief's house. So given that that's the chief's house, that's kind of the top end of the infrastructure in that community, and you can see that there's quite a lot of high and dense vegetation once you get out of the center of the village. And it was really interesting having a chat with them to understand what their needs and interests were. So the next village on from them is 10 kilometers away, so about 6 miles. And there's a lot of extended families that are spread between the two villages. And we noticed driving between the villages that there's always people walking along the road to get between them. So even during peacetime, you think about the lost time, the lost energy that, it could be doing more productive things for people that are really, subsistence living. And so one of the things that we hope is that we can actually, make life that little bit easier for these folks. And certainly they were very positive and very keen about, the technology, and enthusiastic to be part of the pilot. And it was really a recurring thing that we found with everyone that we've spoken to in Vanuatu and in the Pacific region, that they are hungry to have this kind of technology, because for them, all of these risks and hazards that create the need for something like Serval are just so much more acute and chronic. So, there's almost always a cell tower down somewhere. There is plenty of population who live in areas where the coverage is bad or non-existent. People are wandering around, the financial means that people have to, they have to ration their use of commercial communications because of their income levels. And so, creating something that can supplement that so that they don't have to spend their money on the local comms. They can spend it to speak to people further afield that they want to in the next village or wherever. Which actually leads into an interesting point that we often sort of have people comment and saying, oh, aren't carriers going to be afraid of what we're doing? And our view is actually there's actually nothing for the carriers to fear. In fact, good integration with a carrier, and we're talking with a couple of different carriers at the moment about implementing a two-way SMS to mesh gateway, because then people from beyond the edge of the cellular network can start sending and receiving SMS. And of course, that generates revenue in both directions for the carrier. So it will actually add revenue. And what we actually find is that people's communication spend is actually pretty fixed, that people work out how much they can spend on communications and they spend that. And if there are ways, like as people start using WhatsApp and all of these things now, it hasn't really changed how much people spend with their carriers, that they just now do different things. And so that's one of the things that we're actually very keen to try and get some hard data on, because I think once we can show it for one carrier that there's nothing to fear, then that will, really facilitate these kind of partnerships at a more global level.
Yeah,
well, I think sorry,
Randy. That is very interesting because you're extending and expanding their reach, the reach of any. So there is a partnership there in the offering.
Indeed, and so one of the really interesting things in Vanuatu, so we have a very positive and cordial relationship with their equivalent of the FCC. So it's the radio telecommunications regulator in Vanuatu. Because what they can see is that their cellular networks, they have a universal access plan, which is due for completion at the end of this year, that will have 98% of the population's permanent residence locations with access to 3G or better connectivity. And that's taken a lot of encouragement to get the carriers to put in the towers needed to get that coverage. And both the regulator and the carriers are fully aware that to push it out to that last 2%, which of course is probably 40 or 50 or 60% of the land mass, it's simply infeasible economically to do. And so the carriers are, generally speaking, positive there about what we're doing, because they can see this is a way to get coverage to those last people, and that from their perspective, that makes their customers and the regulator happy. And of course, the regulator is interested in there being true universal communications access. And also, of course, Vanuatu averages 3 cyclones a year. In fact, this year already, even though we haven't actually got into the main cyclone season, that begins sort of November, they've already had 3 or 4. And whenever they come through, this knocks out phone towers. And so they have a very acute and chronic need for temporary communications when that happens. So we could almost end up with the ironic situation where Pang Pang and Apau villages continue to communicate when the next big cyclone has gone through. Meanwhile, Port Vila and Luganville and the big cities are actually knocked out, waiting for their cellular infrastructure to come back up. Of course, in time, we hope that the technology will be much more widely distributed through the country and through the region.
Yeah, yours is a further level of resilience that could also be introduced in urban areas.
Yeah, so this is actually where it gets really interesting. To make it scale to large urban areas is actually very, very hard. Scalability, because we've designed the cockroach of the telco world. And it works very well when the infrastructure is not there. Cellular, on the other hand, works fantastically when the infrastructure is there, and as a result can scale very well, because you can get the bandwidth and you have the structure and the routing and all of those kinds of things. The kind of use cases we're looking at, it's just not possible to do that. Indeed, we say, what can we do when that's not possible? And so the scale limits, we don't know where the hard limits are. We continue to try and, grow the size of network, grow the number of devices that can be in range of each other at the same time without them all, trying to talk all over each other. And so it's going to be interesting to see where that limit is. But we see what we've done very naturally fits in to fill the gap. When an individual cell tower goes out, or in a rural area where there was nothing. So, we think up to some thousands of users in an area is feasible. And so again, this is another reason to say that we complement rather than compete with existing telcos.
I think it's would be a valuable thing to try to imagine in your head what it was like 200 years ago when someone was on the other side of an ocean or even in another village. You'd still have to ride over there by horseback. There wasn't actually any way to reproduce photos, by the way. So in an emergency situation, I mean, not necessarily a community emergency, even maybe someone is having a baby. And, we live in the first world where it's nothing at all. I mean, God, people are posting photos you don't ever want to see even on Facebook, let alone, I mean, it's their dogs even, Corrado. We're waiting for that one.
Yes.
But the point is that we are so spoiled by this that you need to take a step back and look at someone in the next village and their family. Someone's having a child or someone has been injured or what, good news or bad. It's a major scene to send something. Somebody has to either run over there or ride an animal or something, or maybe they have gas vehicles or whatever. But the point is, there is no instantaneous. So, and as far as images go, what are you going to do? Print the photo and bring it? So my point being, I think this is amazing technology for people who are in an area where they don't have what we're talking about. And in that case, this whole send and forward, I forgot the exact, store and forward, is that what you're calling it?
Yep.
This is brilliant. I mean, this is the way things were done when people rode around on horseback, except they didn't have images. My question to you, Paul, about implementing this, two questions regarding cost, because I would assume that there are smartphones in the sense of the lowest end that could do all this stuff. What kind of price or type of phone are we talking about here? It doesn't necessarily have to have a SIM, so there's no cost there. What ranges of phones, and also a little bit on the idea of what the extenders are going to cost?
Sure. Okay, so in terms of phone support, any Android phone is actually, we've yet to make an Android phone that can't run our app, because they all have Wi-Fi. They typically all have Bluetooth. Partly, being based out of a university, we buy the cheapest, nastiest phones. So, in fact, we haven't tried it on a G1 lately, but that's probably about the only phone that we find that it wouldn't work on. So, yeah, we have cheap HTC phones. We had Huawei phones that cost as little as $29 Australian from the supermarket that we've tested it on. The phones we're looking at in Vanuatu at the moment cost probably about $50 US and run the software completely fine. The mesh extenders at the moment, because we are just making those in the lab, the cost of those, we don't know the final cost at the moment of the small batches, because we're still, there's only 10 of the new mesh extenders that actually physically exist. We're getting another batch of 50 made at the moment. There's some fun manufacturing challenges there as we keep tweaking the PCB to try and get everything completely right. In the first instance, we think that they'll be about $500 US a piece, which for NGOs, Red Cross, and those kinds of organizations to have a forward deployed capability is completely affordable. Fundamentally, there's no reason why they couldn't cost under $100 US. And remembering that each mesh extender can support potentially 50 or 100 people connected at once within Wi-Fi range. So in a village, and so one of the things we're going to find out, how many do we need in a village to provide decent coverage? And my gut feeling is it's going to be 1 to 5 is actually sufficient. And then if any one person walks from village A to village B and they both have a mesh extender, then that will actually cause delivery of traffic between those villages as they wander around. And that, that's assuming that they can't get line of sight between them. And actually, in Vanuatu, we know that getting line of sight between villages just is not going to happen, because you've got 20-meter high, thick, dense tropical vegetation that's also full of water and all sorts of radio unfriendly properties to it.
Yeah, of course.
Fascinating stuff. I mean, this is really amazing. And yes, NGOs, if their mission is to help in these areas, the budgetary considerations are not really insurmountable. I mean,
one of the key things that we have done, because of course the whole development of the mesh extender has been done on a non-profit, non-commercial basis. So it's all grants that have paid for the product development. So which has been So it's about 2 million Australian dollars, which with our dollars just climbed up the hill again. So that's about 1.6 million US dollars has been spent on R&D, tooling for the injection molding and all of that kind of thing. We don't have to recoup that. If we had to recoup that, the mesh extenders would have to be prohibitively expensive, thousands of dollars apart. But instead, it's going to be hundreds of dollars. And as I hope, down around $100 should be totally feasible, if we push production up to thousands or tens of thousands of units.
Are there partners with whom you're working who could be mentioned as just to see who's doing what, or this question out of the blue and out of my head, out of the blue?
Sure. So the main partner that we're working on in terms of the manufacturer, so the folks who make the UHF packet radio that we use is RF Design. I'll pop their URL into the into IRC. So they make the RFD 900 series of packet radios, which we chose because they're not the cheapest one, but they have very good performance. So this is why we can get 4 kilometers at a quarter watt. And that's, I think, at 128 kbit per second. So, we can do quite useful things with those. So we've actually, those guys have our design partner for the main board in the mesh extender. So all the electronics inside the box is made in one place. And that makes a whole pile of sense for them and for us, because they like to sell their radios. We want the units. And so that's been a really nice relationship. We're also talking with, there's a recent Kickstarter. Let me just try and find, as an example of other kind of groups that we work with. So this one's not totally confirmed yet, but the folks who are doing Sonnet, they want to do off-grid mesh mobile communications as well. And so we're talking with those guys about actually making sure that their hardware is interoperable with the Serval mesh. Because what we're trying to do at the moment is to create a platform so that people can go, okay, we can make things that are Serval compatible, and then everyone gets the benefit. Everyone can further amortize the software development as we keep refining the protocols and things. So we're hopeful that we'll be able to work out a way to do that with the guys at Sonnet and with others. So my hope would be that within a year or two that we have a Serval compatible trademark kind of thing with a star rating, and so that products will hopefully start coming out saying, yep, this is a 3-star or a 5-star product in relation to the Serval mesh.
Okay, excellent. We have Jay Carpenter with us, and he has a question for you.
Sure.
Hello, Paul. So my area of interest is in the naming, addressing, numbering, and identity. And I was kind of curious as to what you focus on for discovery and for addressing. Is it the telephone number? And what if somebody, their telephone number is unknown? What sort of issues and circumstances and situations have you run into regarding the addressing?
Sure. So this is an area that's in a bit of flux for us at the moment. So if we go back to the origins of Serval, one of the little innovations that we made was a means to basically do a phone number ARP. So when you would dial in the dialer in the original Serval mesh app, it would basically send out an ARP across the mesh network asking if any device had claimed that phone number. And then that would resolve that into a SIP address and then establish the call. And so that was a very nice piece of completely distributed numbering and resolution that really was the unique piece of glue that we actually made. The rest of it was actually just taking existing technologies that were out there. Now that has a number of advantages and disadvantages to it. An advantage, of course, is that you can simply dial by number and you don't have to, there's no central authority looking after a database or anything like that to break. On the downside, you can't be sure that the person who's claimed the number is the real person who actually owns the number. So you need some kind of at least contention resolution thing where you can say, hey, 3 people have claimed that number, and warn people and say, okay, well, talk to one and see whether it really is your grandmother or whoever you think you're calling, and be alert. But in a disaster situation, that's actually preferable to defaulting to preventing people communicating, because the whole point is that they can't communicate and they want to communicate. So in that sense, we work in a different trust and security parameter than what you would normally expect. Now, that said, we're evolving that forward to provide considerably better properties. So we now have an identity card mechanism in the new Serval chat app that pushes out across the mesh store and forward. That's digitally signed with a self-signed certificate, because so all of the addressing on the Serval mesh now is not IP based. We have our own protocol that uses public keys as the network address. And that one thing simplifies so many things, because you don't then need to have a central authority at a fundamental level. Once you've identified that a party is who they claim to be, you just remember their public key and you can talk to them end-to-end encrypted as often as you want thereafter. So again, I'm not saying that we have perfect solutions to all of the issues that come up, but we have what we think is a fairly pragmatic and reasonable solution to a lot of these problems.
That's really, really awesome. I don't know if you follow the IETF STIR initiative, which is Secure Telephone Identity Revisited. But what you just described and what you've explored, I think could be very, very interesting to many, many people. So I might follow up with you directly.
That would be fantastic, and we can try and follow up with them.
Yeah, that would be awesome. So have you, in your deployments, I don't know how far you've gotten with your deployments, but have you experienced any sort of breakdowns in authentication and identity and authorization and all that sort of thing? Have you experienced any breaches? Let's put it that way.
The scale where we're expecting problems with that, like we haven't seen adversaries trying to impersonate people, which is the main weakness that we currently have. And a related one is actually, because you can roll a new public key and put a business card on it and claim to be who you want. And, how do you delete one of those? Or how do you, there's a whole reputation kind of model that you need to do, as well as a revocation mechanism as well, and having a sense of expiry, so that if your old phone got run over by a camel or whatever, and now you've got a new one, but the old identity is floating out there, people are trying to send text messages to the old you, not the new you. So this is an area that we would like to put some more attention into, to really refine. And this is the two-edged sword of doing everything, based in a university on grant income, is that we typically only have between 1 and 4 people working on the technology at any point in time.
There are some folks that are looking into using blockchain technology to address that very issue that you're talking about, where you have this dynamic addressing that, a phone number is mine at one point in time, or something that looks like a phone number, and then later on it gravitates to somebody else. So very interesting. So.
Yeah, and that would actually be quite an interesting way to solve it. I mean, things like blockchain can work quite nicely on the mesh, even though in principle the bandwidth requirements can be quite high. At the end of the day, you're trying to replicate something among many people, and that's what store and forward actually does most naturally, which is, as we've been looking to add in the Twitter-like functionality, it's quite funny, because it's really about taking away the filter on private text messaging, so that it still transfers in exactly the same way on the network. It's just that it's addressed to everyone instead of to one person. And
very cool.
The blockchain is similar.
Awesome.
Anyone else have any questions? If you're on ZipDX, you can hit *6, assuming you're muted, and that will unmute you. Otherwise, while we're waiting to see if anybody does that, or looking at IRC, of course, I don't know if Michael's on a call or if he's with us here and he has anything. He actually looks like he's talking to somebody, so we'll skip that part.
I
What
was
have
just
we not?
I'm talking to you guys, and I've been listening quite happily. Forgive me, I did have to take a call mid-span there. Are we where are we in real world users? Have we deployed? And this comes from the perspective of somebody who lived through Hurricane Ike and knows what it's like when even in the developed world our communication systems falter for days or weeks at a time.
So we've had that we're aware of, and this is one of the things with the fully distributed technology. We don't know how many real deployments there have been because the app doesn't phone home. It can be copied from phone to phone, in the middle of the wilderness and never come back in contact with the internet. What we do know is that there's been more than 100,000 downloads. What we also know is that when there's unrest around the world, we tend to see spikes of installs from Google Play. So we had an inkling that something was going on in Ukraine before, in fact, even their president ran away to Russia. We had an inkling that there was something going on in Turkey before there was unrest in local elections. We had an inkling that there was something going down in Iraq before ISIS popped up on the scene because of these bursts of installs. But the two confirmed deployments that we're aware of, so one was with the very, very early version of the software, and that was in a waterfront community in Nigeria with, I think it was 10 or 20 users who the local government was trying to evict them from their waterfront property so that they could, sell that property for a fortune, even though these people have been living there for a couple of, their ancestors for a couple of hundred years. So they used the technology to coordinate themselves and with Amnesty International, and it worked quite well. So that was ad hoc Wi-Fi between the phones, no mesh extenders because it was before the mesh extender era. So that was quite interesting. And then the more recent one, talking about Ukraine and Crimea, we got an email from someone who was in the Ukrainian armed forces to say that they had made they built their own mesh extenders designed for use in the field because the Russians were targeting their regular cellular communications either by jamming them or radiation-seeking weapons. And so they were actually getting ready, from my understanding of what was said to us, to scale that up in the battlefield before the Canadians came in and gave them, regular military radio equipment. Now, this isn't to say that we're not actively interested in serving military use cases. If people, it's out there as open source, we can't stop anyone using it for any particular use case. But it was nonetheless very interesting to us that they saw a problem that is in many ways very similar to disaster zones of deprived communications, and they found that our technology could provide a solution where nothing else that was feasible for them to access was able to do that.
In that, and forgive me if this was answered earlier, but is good solid crypto involved, or?
Yeah. So the network addresses on a Serval mesh are 256-bit elliptic curve public keys. So everything is intrinsically end-to-end encrypted quite strongly. In fact, if you want to send something that's not encrypted, you actually have to, in the APIs, you actually have to specifically say you want this packet to be non-encrypted, because we don't want insecurity by default because people haven't taken
crypto
the right
by
step.
default. Woohoo!
Yeah.
Yeah. Excellent.
And that, I think, was another appeal for the Ukrainians, was that they at least had some hope of privacy in the communications at that time. And so now we're in the process of rolling this pilot out in Vanuatu, which will be the first deployment that we will have been on site for to try and support. And so that's going to be really interesting. We hope that we will have those networks in place and already used to some degree by Christmas, and then over coming years we hope and expect to support them. It's been really interesting that every time we go to Vanuatu, we keep hearing about more potential use cases. And now we're talking with the Ministry of Health about using it to support public health surveillance in remote locations. And the disaster management organization would like to be able to use it for, sending out alerts ahead of disasters happening. So it's really interesting.
Yeah, excellent.
I have a question I should have asked a long time ago, probably. It's with regard to installing, and it's a very simple question, and maybe somebody else will be a little stumped by this. When I Bluetooth the file over, the APK over, there's a notification or something, you click on that and it doesn't know what to do. And then as it happens, I have file managers. So the file manager, if you go through and find it in a file manager, you're okay, because then you click on it and it will install. But if you don't have a file manager installed, is there some simple way to do this? I'm saying this in case people have gotten to this point and are dying to install it to play with it and see how it works. Is there some workaround?
It varies from phone to phone, and it's just one of the nuisances of Android. But at least in Android, you have the hope of side loading. On iOS, you can't side load without the internet. And this is actually part of why we focused on Android. In theory, iOS has a peer-to-peer communications framework. And we intend to support that in an iOS version, but it will still be the poor cousin to Android, not the least because the phones cost 10 times as much, but because you won't be able to install it on a phone in the field, during a disaster. And again, I think this is the interesting thing, that both the what was done in Ukraine and what we're planning to have ready with Red Cross National Societies in the Pacific is the ability to deploy a mobile phone network while a disaster is underway. And we're not aware of anything else that exists that lets you really do that, that doesn't involve, large aircraft and, cell towers on wheels and all of these things that the logistics simply take too long to get happening. I mean, the origins of Serval was watching the aftermath in Haiti, and that whole process was just really interesting. That that because of the damage to the to all of the infrastructure, they could only get a plane in or out every half an hour for the first few days. And you're trying to get people on the ground, you're trying to get enough food and water to support them, you're trying to get food and water to support the people that are already there, and you're then trying to also get communications gear in to fix broken parts of the communications network. And it's just, there will always be this gap, and the smaller the things you have, the shorter that gap will be. And that's what we're really trying to do. We wanted it just to be phone to phone, and we can do that with Bluetooth at a local level, so that gets the gap down to minutes, and then it might be hours to a day, depending on where mesh extenders are pre-positioned, and they run on solar panel. You don't even need to have a battery on them if you don't want to. It'll just work when the sun shines. For that next phase, so that in that whole hierarchy, and then eventually, of course, the cell networks will come back up, and we're not needed anymore in that sense. And then the kit can either stay there ready for the next one, or it can get brought back in, ready for redeployment.
I wonder if there's a device that is sort of a Wi-Fi access point, but it's actually has no internet connectivity. It's just a Wi-Fi access point that is also a file server. And when I say that, I mean, there probably is, but what I mean is something that's handheld like a phone, or maybe an app that runs on a phone, because that would solve the problem of the platform.
Sure,
and
DDWRT does that. DDWRT does that, right? If you have, if the little router has a USB port, you merely plug some kind of storage media to it, and away you go.
And so the mesh extender is an OpenWRT router with a UHF packet radio.
Right. That's, of course, it's true.
Yeah. So that's your generation 2 of the of your mesh device with some memory inside, or a RAM or a ROM module with your APK to download from.
Yeah. That's right. I mean, as long as you can get it anywhere, then you're fine. But of course, if you have it on one phone, that phone actually has storage and can run a Wi-Fi access point and can actually be the means to download it. And
it's one of the things
that
I downloaded that on your application from Google Play on the phone that is connected, was connected, and then I beamed that across with Bluetooth on one phone and then across onto another. The only problem that I had on the applications on the other two phones is that you need to enable the installation of non-authenticated device apps.
Exactly, and there is no way around that. Unless, I mean, our hope would be that as we move forward, it might be that the recognition of the importance of this kind of technology means, so in somewhere like Vanuatu, it wouldn't be implausible in a year or two's time if everyone really likes it and the carriers like it, that it actually just comes pre-installed on every phone sold in the country as one solution to that. More globally, it would be lovely if, working with someone like Google, we could say, okay, the Serval Mesh is a special app. Either it just comes on Android, full stop, end of story, or it actually has special dispensation to be installed, so that you can do side-loaded updates without needing to have the special permission, that you can attach there could even be a time and geography limited additional certificate to the APK that says, hey, this is an APK which is trusted for side loading in these particular environments. So that
sort of whitelisting.
Life can be made easier. But also the web server on the mesh extender, when you connect to that, we're actually planning to improve that so that it detects your version of Android and guides you through that process more readily. So it can say, oh, you're on, it's an Android 6 device. So, go into settings, go here, click this. This is what it will look like. And, when you've done that, then, jump back here and do the next step and try and, help people onboard in an easier way that way.
I was just showing the what you're going to find if you go to Google Play. Go ahead. And Michael, did you have something?
No, I'm good. Thanks.
Okay.
So, Randy, to circle back to your comment about having sort of a node that's also a file server and so forth, which and is part of a mesh network distributed architecture. What you described is at the heart of something called the Interplanetary File System, IPFS, which is a different approach to network topology and architecture and so forth. So, Paul, are you familiar with the Interplanetary File System, IPFS?
When the IPFS has popped up somewhat concurrently to the work that we're doing, and again, our lack of human resource bandwidth to really keep on top of everything means that we're only sort of incidentally aware of what they're doing. But certainly, I mean, bundle protocols, because NASA has this, these bundle protocols for these same kind of purposes. These are all related technologies in this space, because if you think about it really, I mean, space is the ultimate disaster zone. You have no infrastructure. The only advantage you have in space is that orbital mechanics lets you predict when links are possible. And my recollection is that the NASA bundle protocol and IPFS tries to use these scheduled opportunities to do transfers, whereas we have to be totally opportunistic because you can't predict where someone's going to walk with their phone. So we have to do flood-based routing. Well, the routing it's perhaps a misleading description, because we're not doing packets, we do bundles. So this is a file with an envelope of metadata, and we replicate those, and we do that entirely on a single hop basis. And this also gets around one of the normal problems of mesh, two key problems with regular mesh networks. One is that your bandwidth halves for every hop because of, it's kind of going through. And of course, TCP misinterprets packet loss as congestion and backs off. And so your end-to-end bandwidth on a network where you have high packet loss is just terrible. And these networks tend to have high packet loss. We found very early on that SIP was a hopeless protocol to try and use for mesh telephony, precisely because of that. Like you would ring someone and their phone wouldn't ring for 90 seconds because it missed the first ring notification in SIP. That was quite entertaining to discover. So we made our voice over mesh protocol. We made our Rhizome, which is our bundle-based protocol. And have really found that, the way the internet does things is fantastic on the internet and completely hopeless in a disaster mesh network context. And so the protocols look very different and have very different strengths and weaknesses in them, and that's just a natural part of the process.
That's awesome.
Why am I hearing David Rowe in the back of my head? I'm hearing David Rowe.
Yeah. So David Rowe actually lives not far from here. So we have this funny little cluster of crazy alternative communications work happening here in South Australia. We
interviewed David Rowe 5 or 6 years ago, and I will say he mentioned Serval, but I think it was in your earliest days.
Yeah, it was. So David came with us. So that Serval began in January 2010, following the Haiti earthquake. July 2010, we had the very first prototype made in these, G1 phones with this horrible cobbled together mess. And to get the project started, I realized that, trying to do an academic publication was not going to be the way to make this happen quickly. So we instead engaged with media and with National Science Week and sort of a few groups to try and get some public attention to the potential of this technology. And so it was quite funny. We ended up chartering an 11-seater plane up into the outback to Arkaroola, where we do our testing. And David Rowe was one of the people who came up with us on that plane. And so if I can find the video of that news piece, David Rowe is actually in that as one of the people I'm talking to on the phone.
Yeah, we were discussing with him what was then called the Mesh Potato, and also Steve Song from the Shuttleworth Foundation, who's also a Canadian, as am I.
Yes. So the Village Telco was in fact the inspiration for the early versions of the Serval mesh. So if we think about the first version with SIP and all the rest of it in a regular Android phone, that was exactly basically cramming the Mesh Potato software plus this crazy mobile telephone number ARP process into an Android phone. So I've just pasted the URL to the link for the video for the original TV coverage that we had, and you'll see David Rowe in there talking on one of the phones at one point. The media coverage is always a funny thing. I mean, it's tremendously effective and very helpful, but you can never quite control how things turn out. And so one of the things, if you watch that video, you'll notice that the audio quality in the call, when they kind of have a call on air to add to that, sounds horrible, because the only audio path we could get from the phones was to put them into speakerphone mode, and then we had the most horrible feedback that made it sound like we were talking on an old analog radio at the edge of coverage, when in reality it's quite clear digital audio.
Excellent all around. Here's the URL. I hope I spelled it right, because that would be a shame to have gone through all the work of putting the background so you can read it. But there it is, servalproject.org. And I think from there you can get the link to just about everything. Paul, I want to thank you really, really a lot for putting up with, first of all, the hour, and second of all, we got a very late start. It's very unusual. I swear this almost never happens. It's happened once or twice. But so thank you very much, Paul, and we wish you all the very best. And hopefully you'll get some new context from all of this. Jay Carpenter is one.
Yeah, that'll be great. And really, it's been a pleasure. It's been great to talk about. It's always great to see how we can make the world a better place as we all work together in these different ways. So thank you very much.
And I think you are doing that. And by the way, there are many YouTube videos. Do you have a YouTube channel? I can't remember, because you have a bunch of videos that people can see.
Yeah, I can't remember whether we actually have a formal channel or not. I don't think we do.
They could look you up though with a search.
Yeah, you should be able to find me with a search. And we're actually hoping to get a few more videos up as we do some of the work in Vanuatu as well.
Well, there'll be this one, of course, and also you did a TEDx Australia.
Yeah.
And that's actually pretty extensive. So I recommend people go to that. I'm sure that's easy to find. Okay, with that, we're going to close it out. Thanks to you, Paul, and thanks to everybody who participates in these things. Thanks, Jay, Corrado, Michael, of course, who's a co-producer and does all of the work, actually. I don't do anything. I'm just sitting here. And we will see you folks next week. Thank you.
Cheers.